Here is an explanation of the first matrix transformation question. And so it gives you matrix A, it asks you to describe fully the geometric transformation. And so the first thing I can really say about matrix transformations is you want to refer to the formula booklet, because in the formula booklet you're going to find this information, which is showing you that a matrix C of the form K001 is a horizontal stretch parallel to the X, and a matrix 100K is a vertical stretch. And so our matrix here fits this image in the fact that over here in the corner that we have K, we have 3. And so that's essentially answering for me the question. The first transformation that this matrix makes is a horizontal stretch parallel to the x-axis with a scale factor of 3. And then we continue to look at it, and the 2 is corresponding to this lower k. And so we know that this matrix actually has 2 transformations, one horizontal, but also a vertical, and that will be a vertical stretch parallel to the x-axis with a scale factor of 2. You need these important points. You need that it's a horizontal stretch, that you need that it's parallel to the axis, which axis you're talking about, and what is the factor. The question was worth 5 marks, and the 5 marks are naming that it's a horizontal and vertical, which axis it's parallel, and then the scale factor. So there is the first part, part A. And then if we look at the next question, part B, says we have a pentagon which has an area of 7 centimeters. It's transformed by A. Find the area of its image. And you won't find this in your formula booklet, but we need to know what our transformation matrix is, because the determinant of the matrix is the scale factor for the area. So the determinant of A, if you think back, it's multiplying your 2 diagonals and subtracting 2. So I have 3 times 2 minus and 0 times 0, which is 0. So the determinant of this matrix is 6. And so therefore the area of P will equal the area of the original, or then I should say it's P's image, is the area of the original times the determinant. So we have 42, and they give me units, centimeters squared. So whenever you talk about the area of a shape and its image, the determinant is the scale factor. And again, that information is not in your formula booklet, something you need to remember. So there is the second part, B. And now we look at the part C. We have matrix B is defined by this matrix. It represents a combined effect transformation represented by the matrix X, followed by the transformation represented by A. I want you to find matrix X. Now, the important thing to realize here is what they're telling you is matrix B is equal to the combined effect of transformation represented by X followed by A. Now, the order that you write these 2 matrices is important. If you think about it, you would have some shape that you're going to transform, and And it first says it's a combined effect represented by X followed by A. So X should be first, closest to the shape, and then you would do this multiplication and then follow it by matrix A. So it's important how this order is written, because if they want me to find X, then what I really need is to multiply with the inverse of A. And again, it's important to think about the order. So I'm going to write A next to X so that these two combine and basically cancel each other out. And because I've written it to the left, then it's to the left of B. So these become the identity matrix, which is 1. So what we're really saying is A inverse B is equal to matrix X. Now, because this is a 3-mark question, they must expect for you to do this on your calculator, which means typing in matrix A, so you can then use the inverse of A, and typing in matrix B. I don't have my calculator right here, but on my calculator, I would type it in as 1/2 or 0.5 inverse of matrix A times B, hit the equal sign, and you'll probably get a matrix that is decimals. It turns out to be, without decimals, the square root of 3/2, 1/2, negative 1/2, and the square root of 3/2. So that is what matrix X is equal to. And we're going to need that information here in a moment, because question D asks us to describe fully the geometric transformation of X. Matrix X, we said, was the square root of 3/2 and 1/2, negative 1/2, and square root of 3/2. So we'll back to your formula booklet, and in it, it has these two transformations where we have the cosine of the angle is anti-clockwise or clockwise. And how do I recognize this to be a cosine? It's really coming from the fact that I have this square root of 3/2. If you know trig identities and trig functions, the square root of 3/2 and 1/2 are all related to a 30, 60, 90 triangle. Just basically, if you have a 30, 60, 90 degree triangle, then the 30 degrees will be half of X, X being the hypotenuse, and the longer side opposite the 60 degrees is the square root of 3/2 X. And so that's how I recognize this to be a dealing with cosine sine. Now, the thing to look at and think about is this fact, and that is I'm looking at the pattern here. So I have positive, positive, negative, and positive. And when I look at my two options here, it's this bottom one that follows this pattern. And sine 1/2, or my 1/2 is over here, and it's opposite 30 degrees, which tells me we're talking about the sine of 30 degrees. And so for this geometric transformation, I'm given this information. It's a clockwise rotation, of 30 degrees, and I figured the 30 degrees out based on this right triangle, and it's about the origin. Again, a 2-mark question because this matrix you got from part C, and then just being able to recognize, and really I would be looking for halves because halves relate to the 30, 60, 90 triangle, and then I look at the pattern of these numbers and compare it with the pattern of my transformation matrix to recognize which one is the correct direction, anti-clockwise or clockwise. That is important. So there is an explanation of the first question of matrix transformations.